Hello students, let's start with the preparation of amines by the first method, that is ammonolysis. So let's start with the method. The method for preparation of amines, that is nothing but from alkyl halide. Now what we are doing into this is we take an alkyl halide and treat this alkyl halide with ammonia in the presence of alcohol. Now what happens, students? Let's see. Nitrogen consists of one lone pair, if we are not wrong. Now, out of the three hydrogens of nitrogen, one hydrogen combines with the X, giving us HX as a byproduct. So what we are remaining with is nothing but RNH2, which would combine to give us a primary amine because it consists of an NH2 group. Now, let's see further. If this entire reaction was seen, then what was the first step which we did? Then we did a nucleophilic substitution reaction in this, and as the alkyl halide was broken due to ammonia, the reaction is called as ammonolysis, or also referred as Hofmann's ammonolysis. Also, one more point, this is also called as alkylation of amines because we took NH3 and we added an alkyl group to it. Now, let's look further. We got a primary amine, right, students? Let's do one thing. Add one more alkyl halide into this. So what we would get? Once again, out of NH2, one hydrogen would combine with X, giving us HX that would be formed. And now what would happen? We would get a compound that is RNH2, or rather we would get R2NH, that is a secondary amine because it consists of NH group. Now let's see further. Let's take this secondary amine once again, and this secondary amine was again treated with RX. What would happen? Once again, it consists of one hydrogen. That one hydrogen would combine with X. So naturally, X would be removed. You would get a compound that is HX. Now what you are remaining with? You are remaining with nothing but R3NH. That is, you are now having just a nitrogen, means it is a tertiary amine, right? Now, the reaction does not stop over here. Let's see. Suppose to this tertiary amine we add one more RX. Now what would happen? Now nitrogen consists of one lone pair, right, students? This nitrogen would donate a lone pair towards the R group because it is electron deficient. So now what would happen? You would get a compound that is nothing but NR4 times X minus. And this entire compound would also be represented as NR4 positive X minus. And what is it called as? It would be called as a quaternary ammonium salt. So, what else you get? In the entire reaction, we first got a primary amine, next we got a secondary amine, thirdly, we got a tertiary amine, and the last product was a quaternary ammonium salt. So this was all about the reactions. Now, let's look at the limitations of this reaction. The very first limitation was that in this method, only primary amine could not be obtained. What you would obtain is a mixture of primary, secondary, tertiary and quaternary ammonium salt, which is very difficult to separate. So would you use this for primary amines? No. The second limitation of this method, or rather a note for this limitation, is that if you take excess of alkyl halide, then quaternary ammonium salt would be the only major product, and vice versa. So now, if we say if ammonia is taken into excess, then primary amine would be the major product. Let's look at the second limitation. In Hofmann's ammonolysis, we could not prepare aryl amines or aromatic amines. Why so? Let's see. Because aryl halides or aryl amines does not undergo nucleophilic substitution reaction due to resonance. They prefer electrophilic substitution reactions. The next point which we would state over here, tertiary butylamine cannot be prepared by this reaction of alcoholic ammonia on tertiary butyl halide. Why? Because a tertiary alkyl halide, it tends to undergo a elimination reaction rather than a substitution reaction. Let's look at the reaction. First of all, we took a compound that is tertiary butyl bromide. We treat it with ammonia, NH3. Now, NH3 can be written down as NH2H. Yes. Now, what is the product that we are obtaining or we are expecting is that H and Br should combine, and then you would get HBr, and along with this, what you would get? You would get a compound that is nothing but tertiary butyl amine. Right? But now what happens over here? Let's see. What happens exactly is hydrogen from one of the methyl groups combine with NH3, giving us a NH4 molecule. Now this NH4 is positive. To this, Br gets attracted, giving us a compound that is nothing but the first compound, NH4Br. Now when this NH4Br is formed, then you would obtain a corresponding alkene that would be nothing but 2-methyl propene. So here the substitution reaction was not preferred, elimination was preferred, and because of this, tertiary butyl amine would not be formed, or rather it would not be the major product. This was all for this module, students. Meet you in the next module. Till then, thank you.